Growth and decay using logarithms, example 1. A farmer monitoring an insect plague notices that the area affected by the insects is given by the formula a sub n. I will just copy it here. A sub n equals 1000 times 2 to the power of 0.7 n hectares, where n is the number of weeks after the initial observation. So this n is in weeks and a sub n is in hectares. Now I can replace these variables. So this variable would usually be depicted on the vertical axis and this one would be depicted on the horizontal one, and therefore I can use instead y equals 1000 times 2 to the power of 0.7x. Okay, so this is the function that represents the dependence of the affected area on the number of weeks. This time, however, I'm using a different set of coordinates or variables to in this equation. Y represents a sub n and x represents n. Now in part A, I should draw an accurate graph of a sub n against n to use my graph to estimate the time taken for the affected area to reach 5,000 hectares. So the problem here is that if I want to have the accurate graph, there is nothing better than to use technology. So therefore I'm going to use GeoGebra. This is the GeoGebra Classic, so let me input the formula. Y equals 1000 times 2 to the power of 0.7 times x. So this is the graph. Well, you may think, where is the graph? Well, it is here. You may zoom out, but you see the graph is very, very steep and it has not reached 1000 yet. So you see there is some problem here. What we need is to use a different scale for the x and for the y axis, because you see the y-axis increases rapidly, or the value on the y-axis increases very rapidly, while the values on the x-axis should not increase so much. Therefore, there is the function in GeoGebra. If I right-click on the screen, I can choose the proper aspect ratio. I will choose 1 to 1000, and you see what it did. Now my unit in the horizontal direction is this long, while my unit in vertical direction is 1000 times smaller. Now you can see the graph, but still we need to zoom out. This is the affected area at the beginning in time 0, or after 0 weeks has passed, and this is after 1 week, after 2 weeks, and so on. You see that it increases, but we are interested in the moment when it reaches 5,000 hectares, so here. So we can see that it's somewhere here where the value is 5,000, and you may see that the affected area would be somewhere around 3.3 perhaps, because this is 3.2, this is 3.4684, so this is somewhere around 3.3 hectares. We can get even a better approximation if I just let GeoGebra draw the function y equals 5000. Okay, so this horizontal line, and now I can place a point on this curve and try to move it up so that it is on the horizontal curve. Let me show its coordinates. So I would choose settings and let it show the value. Value means here the coordinates, and you see that it's around 3.32 when the vertical value is 5000. I can do better than that. I can zoom in and set it more precisely. So you see I can get this close to 5000. So you see my approximation for the answer is about 3.32 weeks after the beginning. The affected area should be around 5,000 hectares. So let me write down the solution. So the solution was n was approximately equal to 3.32. Okay, n, or I can say instead of n, I can say x. Okay, x is the number of weeks. These are the variables used in GeoGebra, while these were the variables used in the problem. Now, in part B, so this was part A, we successfully learned this number. In part B, we should check our answer to this part using logarithms and using suitable technology, in our case calculator. So what we want to learn is the answer to the question when, for what value of x will y equal to 5,000. So let me substitute 5,000 for y. 5,000 equals 1,000 times 2 to the power of 0.7 times x. And this is nothing else, just an equation. This is an equation that we can solve very easily. So we divide first by 1,000 to get 5 equals 2 to the power of 0.7 times x. Okay, now let me use decimal logarithms. So I will take decimal logarithm from both sides of the equation. So I get logarithm of 5 equals, and now I can have logarithm of 2 to the power of 0.7x, like this. Now, using the logarithmic, the laws of logarithms, this time the third law, the power rule law, I get the following. It's the logarithm of 5 equals 0.7 times x times the logarithm of 2. So this is the decimal logarithm. Now we need to express x, so we divide the entire equation by 0.7 times logarithm of 2. Okay, so x should be equal to logarithm of 5 divided by 0.7 times logarithm of 2. This is the value that we wanted to learn, and now let me use my calculator to calculate this value to a better precision than our previous approximation. So it should be decimal logarithm of 5 divided by and 0.7 times logarithm, decimal logarithm again of 2, like this, okay, and equals. And what I get is the answer, which is 3.317, and since this is just the approximate answer, again let me use different sign here, so this is approximately equal to this. So you see it compares very well with the original approximation, and it's just the best what we can do using the technology and logarithms to get the answer to the question when, after how many weeks, the number of hectares of the affected area increases 5-fold.